All right, so let's go over assignment number 3. So assignment number 3 builds on assignment number 2. In the previous assignment, you created a static website that had pages connect to one another with hard-coded hyperlinks, and also the content was also static, right? Even though you navigated from one, you logged in as a person or one particular user, or were looking at a particular website or pages or widgets, they were always the same widgets, the same pages, the same websites, right? So we're going to change that using a single page application and reusing a lot of the code that we did for last week, but instead of hard coding all the content, we're going to use them as templates. Templates that contain something that is more generic, that we can be reused. You just have to feed it the data, and then it'll iterate over the list of websites or the list of pages or the list of widgets, right? And will dynamically render the content. The content will be dynamically rendered on the client side as opposed to on the server side. The classical way of doing this would be to dynamically render this on the server side, right? Where you iterate over the data and generate dynamic HTML on the server, and then by the time it gets to the client, the browser, the HTML is static, right? From the point of view of the browser. From the point of view of the server, it's dynamic. All the logic is all the rendering logic is on the server, and by the time it leaves the server, it's static, right? And it reaches the client as a static HTML. Here we're inverting that architecture. When it leaves the server, as far as the server is concerned, is static content, static HTML. But once it gets to the browser, along with the JavaScript code and whatnot, and the various libraries, then it becomes dynamic. It renders the content dynamically by manipulating the DOM, right? By adding or removing or manipulating the DOM programmatically using JavaScript that executes on the client side. Yes, and that's what we're going. That's one of the key features of single page applications. The other key feature of single page applications is that the navigation that occurs as you navigate from one page to the next is fundamentally different, right? On the server, as you navigate and you click on the hyperlinks, all those become individual requests to the server, and the server re-renders the page anew for the client to render as a static page from the client's point of view. So as you click your way through an application, those requests are brand new, the page is brand new, and gets rendered dynamically back to the client. Right? It's a full refresh of the browser, right, of the view, as opposed to in single page applications. We only ever load completely the index page, right? The very first page, where that is the entry point of the application, and then all subsequent requests are requests for snippets or snippets of HTML that are then strategically rendered in the DOM, right, to paint the page dynamically, right? We only ever enter the index page, and then subsequent HTML snippets are then rendered. Now, every subsequent call for those snippets are calls back to the server, but they're done under the covers, right, using AJAX, and the page never re-renders, right? All those requests go as HTTP AJAX GET requests. They get downloaded to the client, and those snippets are used to paint the page. But those snippets are never ever reloaded from the server. They're cached on the client. So as you navigate and the page gets rendered, we don't ever go back to the server to ask for these snippets. Right? Once we have them on the client, they're cached on the client, and then we don't need to call the server ever again. Okay? As opposed to a server side, we would have to create a brand new HTTP request as we navigate between the various pages. So to implement our single page application, we're going to be using Angular as our framework, and Angular forces you to think using a particular architecture, the model view controller architecture, which has been proven very successful on server-side applications that have been around for quite a while, They've been very mature. It's a very well understood architecture. Angular is just reusing these ideas that have worked very well for breaking up large application into smaller chunks that are easier to work with. We're going to create our entry point of our application on the client side. It will be a JavaScript file called app.js. This is very similar to what we did a couple of weeks ago when we demoed the very first Angular application, right? So we're going to do that. We're going to follow that a little bit, but I'm going to be introducing new new best practices on how to break large applications into smaller pieces. We already started doing some of that for assignment number 2. We're just going to keep going and adding these best practices on how to deal with complexity as the application grows and the team that works on it also grows along with it. Right, so we're going to have a single entry point, which will be our index page. We're going to call our Angular application Web App Maker or WAM. It'll load the app.js plus other JavaScript that implements controllers and services and whatnot. We're going to create the views. So we're no longer going to call pages per se. Right? Up to this point, the HTML pages that we've been working on, they have been legitimate pages. They've been standalone HTML pages that if you double click on them, they open up as a, they can stand alone on their own, right? They have their own JavaScript, their own CSS, their own body, header, everything, right? They're full-blown HTML documents. Instead, we're going to rip out most of the content there, especially that content which is common to all the pages so far. You've noticed all your pages probably have a lot of things in common. They have the same head, the same body, the same opening and closing, the same header and footer, right? So all these common pieces, we're going to break them out of here, or we're going to put them in in common files so that they can be reused, right? They could be re-included without having to have this redundancy across so many pages, right? So you'll see that all the pages that we've been working on, they're no longer going to be standalone HTML documents, right? They're going to be meant to be reusable, smaller components, right? That can be then be loaded strategically to then build a larger web page or a web view. So we're no longer going to call them pages. We're going to call them views, all right? Meaning that they're reusable, they're small, they're still meant to be consumed by a human being, right? But they are reusable small components. Sometimes we refer them also as templates, right? Again, with the intention of being that yes, this will be rendered for some user. It is only it has some layout information that needs to be fed some data, right, to render the entire actual view. We're going to move some pages into some directories to start organizing our views. We did some of this already in the previous assignment, right? We grabbed all the pages that had to deal with users. We put them all under a user directory, right? Same thing with websites, pages, and widgets, right? We created dedicated directories for each one of these, right? Following a kind of like an entity organization, right? Based on the entities, we grouped them. Another way of organizing them, alternative way, or in addition, we could have organized them by feature. If you have like a chat feature, then you might have a directory dedicated for chat, right? And that chat might be reused in many different views, right? So again, it could be by feature, or if you have a document feed or something that could be reused, that also could be a directory for that. So we've decided to organize it by entity type. Okay. Also, we're going to start renaming our pages, our views, not pages anymore. We're going to start renaming our views following a naming convention that helps large teams to get their mental model, create a mental model of how the application is organized, right? In particular, the naming convention will be that all these any particular piece of document or any particular piece of file has to follow a naming convention that places it where it is in the application. We're going to refer to each file as an artifact, right? So these are all the artifacts that we're building. Some artifacts will be style sheets. Some artifacts will be HTML templates. Some of them will be JavaScript, right? But each one will have a very specific role in the application, right? And a different place in the application. One of the things here that we're capturing is where in the application does this artifact belong to, right? Is this an artifact of the browser? Is it meant to be consumed by the browser? Is it meant to run on the server? Is it meant for data access? What is it, right? Where in the application does it live, right? And then this helps divvy up the teams so that some teams will deal only with server, some deal with client side, and break it up in that way. Also, next will be the role, right? Or its core competency, or it's a core responsibility in the application. So views capture the fact that this is meant for consumption by a human being. So the role of this artifact is to render something for some human being to read, right? So it should look pretty. It has layout. It has styling and whatnot, white spaces, and it has all those concerns. Yes, it is not concerned with data. It is not concerned with storage. It's not concerned with network accessibilities. Those are not its concerns, right? Its only concern is to look pretty. Okay. Also, part of the naming convention is that the first word will capture the entity type that we're manipulating or displaying, and then some description of what is that we're doing with that entity. So presumably this is a list of pages rendered at the browser, right? And that's the extension, right? Not necessarily the extension will tell you exactly what its role is. So HTML is somewhat redundant, right? Yes, obviously it's client and obviously it's a view, but not necessarily, right? This could have been PHP. This could have been Python. This could have been JSP or ASP, right? Different extensions. And so that might mean that it's rendered on the server side, but it's still a view, right? It's still being meant for being consumption by a human being, but it's rendered on the server. Yes? Okay, so also we'll see later on that some JavaScript, again, it could execute on the server or execute on the browser, right? So those might be ambiguous. So you want to make sure that just by looking at the file name, you immediately place it who's responsible for this, okay? Again, these are very common techniques in industry, to deal with a growing number of artifacts, right? And just managing becomes very complex. If you're working with a small application, this is an overkill, right? But this is a very common way to organize things. Your particular team will have a very specific way of how to organize and how to name the various artifacts, and you should strive to stick to that, whatever the team decided what the naming conventions are. If you have a better idea, you should suggest it to the team, and together the team decides on how to name things going forward. And the intention is that you stick to what the team says because you're coding for the team. You're not coding for yourself, right? It's a collaborative effort. All right. Also, we're going to grab all these entities and all these views, and we're going to put them all under a new directory that we're going to create under the public directory called views. Right. So all the views, right, are going to live under the views directory because we're going to have many other types of artifacts, not just views. Right. We need network connectivity back to the server. We're going to make those services. We need controllers. We need all sorts of other artifacts. Yes. All right. Right, so it's a single-page application. So index will be our entry point. And we're going to create our very first Angular, well, I guess our second Angular application, always using the iffy design pattern, right? Making sure that we're not littering the namespace. We're going to use the Angular module to to create the module, to create the application, also to configure it. We're going to be using routing later today or perhaps tomorrow. The navigation no longer is going to be you're navigating from one page to the next, right? So that's not going to be the server's responsibility, right? It's going to be the client's responsibility of how navigation is going to be handled now. Now that we're doing a single page application, right? In a single page application, we don't actually navigate to another page, right? Instead, we go and fetch those templates, right? And we strategically manipulate the DOM, right, to look as if we're navigating to the next page, right? So we want the same functionality, but it's implemented fundamentally different, right? As we navigate from one view to the next, right? And to do that, we're going to introduce routing. Routing follows the design pattern of model view controller, where we centralize the control of navigation. We make it the responsibility of the controller, right? Of a centralized controller, a navigation controller that knows what should the user see next, depending on the intents of the user, right? As the user clicks and drags and hits different URLs. It should never be the view's responsibility of determining where should we go next, right? It should be the controller's responsibility. And in classical navigation, where you have an actual hard-coded link, right? It is the view's responsibility because the view knows where to go, right? The hyperlink lives on the view, right? And we mentioned last week that those kinds of implementations, you can get into almost like a spaghetti code, right? Where one page refers to another 5, 6 pages, and then you go to the next page, and that page also refers to 5 or 6 pages, right? And you get this, everybody is referencing everybody, right? And it's very hard to follow what the actual logic is of what should happen next. And maintaining that is very, very hard. And so a better implementation is to grab all that logic and decouple it, right? And say, no, it's not the view's responsibility, right? The view should be dumb. The view should notify what the intentions are of the user, that they want to check out, or they want to add something to the cart, or whatever the intent of the user is as they click. They should notify somebody in the central controller, and the central controller can then run some logic, right, that then decides, oh, okay, that's what you want to do? Fine, let's do that. And then decide this is where you should go. It should never be the view's responsibility. It should be a centralized controller to do that, right? And so Angular allows you to implement such centralized navigation controller, and we'll introduce routing later today that maps this high-level abstract intention of a user mapped to an actual physical representation, view representation of where you should go next. Okay. Notice that it's being implemented in JavaScript as opposed to being the responsibility of a view, right, or an HTML. Yes, right. So the view only notifies a central control what the intent is, and then the controller is responsible for deciding where to go next. Okay. This is the routing table where we're going to have on the left hand side we have all the various type of intents that the user might generate, as they click from login to user to a website to a page to a widget. As they navigate across, they generate all these routes on the left hand side, and they're mapped to actual views, right, on the right hand side. Right, so physical views, and these are high level hierarchical intents or routes that the user interacts with the application. Notice that these have encoding in them, where you have some static content plus some dynamic parameterizable data, right? That uniquely identifies either a particular user or identifies a particular website that belongs to a particular user, right? And you can keep going, right? Where you can have a particular page in a particular website of a particular user, right? So the URL here, it's a hierarchical structure that encodes the current state of the application. Right? Where am I? What am I looking at? Right? So it's kind of like a triangulation here of a multi-space data map where you can navigate from a particular starting point for some route, and then navigating deeper and deeper and deeper through the various data space. Right? You first start from a data space of users. Once you identify a particular user, then you can navigate to all the websites for that user. Once you identify a particular website, you can then navigate to all the pages in that website. Once you identify a particular page, you can navigate then to the widgets of that page. Make sense? And so following this hierarchical structure, this allows you to navigate the entire data space in the application, right, and represent it, specifically at a particular view that is responsible for rendering the particular state of the application at that particular data point. Make sense? Yes? Also, notice that it's following particular syntax of parent, then the ID of that parent, then a particular parent, then a particular child of that parent, then a child. So this follows the name, the structure of parent-child, right? That goes all the way down to the leaves of a tree, right? Of a hierarchical tree that represents our data space. Also, this points out another feature of single-page applications, which we'll be revisiting throughout, is that dynamic content needs to be able to render, even though it's dynamic. It needs to be able to render based on some state that is encoded entirely in the URL. Right, so the URL should always encode all the information that you would ever need to recreate the original page, even though the page is dynamic. If it's static, well, it will always be there. The state is encoded in the static content. Right? There's nothing to re-render. That's the content, right? But in dynamic pages, it's much more complicated, right? Imagine in Amazon, if you go to an Amazon page of a particular product, you'll have all sorts of dynamic content in there, right? Reviews from different users, and suggestions of other products, and all sorts of information that changes over time. Yes, and all that information is encoded in the URL. Right? If you copy that URL and send it to someone else, right? Even though the page is dynamic, they can click on that URL and they'll see exactly the same page that you were looking at, right? So the only way to achieve that is so that the URL encodes everything you need, right, to recreate that page, right? Right? We want to behave as if it were static, but it's not static, right? Static, you don't need any parameters. That HTML document will always look the same way. Right? There's nothing to remember, just the name of the document and where it is. But when it's dynamic, right, you need to, since it changes over time, you need to be able to encode everything you need to recreate that page in the URL. Right? So here it is. Right? So this is the URL that we're going to be using to be able to recreate the application at this particular state based on these parameters. Make sense? Right, so that's a very, very important aspect of single page applications and dynamic pages in general. Let's see. We're going to create services. So now that this is going to be dynamic, we're actually going to need some data, right? That's so instead of hard coding the list of users or the list of websites or pages and widgets, right? All that is going to be dynamic, right? So it's going to be perhaps some arrays of some objects. Somebody's going to have to be responsible for holding this data, right? Now, typically, the data would be hosted at some database, right? Some server would be responsible for fetching this data from the database, right, and providing it to the client for rendering, right? But we don't have that yet. We don't have a server yet. We don't have a web service. We don't have a database yet. So instead, what we're going to do is we're going to capture that data. We're going to start with some dummy mock data, right? And we're going to host it in various services right, that are going to be implemented as Angular services. Okay, these services eventually, in the next assignment, they're going to go fetch the data from the server, right? But for today, for this assignment, they're going to hold the data themselves. Eventually, they're going to go out to the server to fetch it, right? But for this assignment, they're going to hold the data themselves. Okay. What we're going to focus on for this week is how to create web services. What typically they go in there. Typically, they would hold they would hold an API. They would implement an API that would allow you to manipulate that data, right? Create new data, remove existing data, update the data that already exists, right? Find the data based on some criteria, right? And so that's the responsibility of services, to be a single point of access to all the data, right, for a particular entity, right? So we're going to be using we're going to be implementing several services, one per type of entity. So one for the user entity, one for the website entities, another one for the page entities, and one for widgets. Each one of them is going to provide various CRUD operations for create, read, update, and delete. Okay? The create, the update, and the delete, they're all going to be looking pretty much the same, right? The create is going to be adding an object to some collection. Delete is going to be removing some object from some collection. And update is going to be updating a particular object with new attribute values, right, in some collection. Make sense? Right? The read operations, depending on the use cases, is going to look a little bit different, right? For the user, right? For the user service, the read operations. We're gonna have 3 read operations for the user. Again, depending on the data type. So if it's a user, you would like to be able to find users in various ways, right? Sometimes you want to find them if you have a username and password, if you're trying to log in. Sometimes you want to find them just by username, maybe when you're registering and you want to check if a user already exists, right? Or sometimes if you know their ID, you want to retrieve them by their user ID. Yes? So you're going to implement all three ways of retrieving. These functions sometimes are referred to as finder methods, right? And they follow a naming convention: find some data type, by, and then the criteria, right? So you have by ID, by username, by credentials, and whatever criteria you would need. Okay, if it would be by date of birth, or by salary, or by whatever, right? So whatever criteria you want to implement, you would have a finder for that, right? And you would pass any arguments that you need for parameterizing that particular finder. Make sense? Okay. So here we're going to give you some dummy data to get you started. Now here we have a minimum of the data that we're going to be using. You're welcome to add more data. Also, if an attribute you think it's missing, if you think we should need an email in there, or a phone, or an address, be my guest and add it. Right? This is the absolute minimum, right? And this is what the TAs are going to grade you on. Okay, on these particular usernames, these particular passwords. All right. So this is how they're going to log in and whatnot and try out your application. All right. So this is minimum. You're welcome to add more. And you're going to create finders and update and deletes on the service. Here we give you a snippet of code just to remind you how to create a service. There are 2 ways of creating services. We're going to look at both. First we'll look at one, then we'll look at another, and we'll see the differences. Right, but here's just one of them. And here's just a reminder. By the end of today, we'll create a couple, so you'll get an idea how to create one. This is just a reminder. For each one of the entities, you're going to create a service, right? Not only for the user, but also for the website, another one for the pages, and another one for the widgets, right? Each one of them is going to hold some dummy data, right? So the user service is going to hold the user data in a user array, okay, in the service. The website service is going to hold the following array of websites. So Facebook, Twitter, Gizmodo, Tic-Tac-Toe, Checkers, and Chess. Okay, and about Go. I heard Google AlphaGo is going to play the best world champion Go player. Let's see how that goes. Let's change the ID to be 890. All right, so here they are. So here's some. Notice that each one of these objects has a developer ID. This developer ID maps to the developers that are here, the primary keys. Notice that all objects have a underscore ID. See that? And these are unique identifiers. Right now we're hard coding these. Eventually, when we see MongoDB, it will be MongoDB who will be creating these IDs. Eventually, right? Right now we're gonna fake it, right, as these strings. Okay, but they're meant to be primary keys, of which these over here are foreign keys. These developers' IDs are foreign keys that refer to individual users or developers. Yes. So you have here 1, 2, 3, 2, 3, 4, 3, 4, 5, and 4, 5, 6. So these websites, for instance, were all developed by 4, 5, 6. These three were developed by 1, 2, 3, and this one was developed by 2, 3, 4. Make sense? So that if you log in as 4, 5, 6, you would see these three websites. If you log in as 1, 2, 3, you would see these other three websites. Make sense? Or if you log in as 2, 3, 4, you would see this other one. Okay? All right. You will create these APIs for manipulating a website. So you can create a website for a given user. So you can have the foreign key back to the owner of this website, the creator of this website. This one is finding a website by user. So if you give me the user, I'll return to you the list of websites for that particular user. Or if you know the ID of that particular website, I'll return that particular instance of a website. You can update a website if you give me the ID of the website and the new data for that website. I'm going to update it and then delete the website by ID. Okay? Right, so some card operations. Pages is going to be very, very similar. This is, we have pages only for website 456. Right? Again, you're welcome to create pages for other websites as well. And so presumably this is maybe going to the Gizmodo site with 3 posts. And these are the unique identifiers. When you create a website, you'll need to create these IDs yourself. Okay, you're gonna have to fake that, create an ID. You could use like a timestamp, or you can say new date, and that gives you like a unique identifier. Right? You'll need to cast it to a string, right? Because the types of these are strings. So these are the CRUD operations for the pages. You can create a page for a particular website, or find all the pages for a particular website. Find a page if given the page ID, or delete a page. Widgets, these are all the widgets, and I think they all belong to a particular page ID 321, 321, 321, which I believe is one of these posts. This one right here, the first post. Okay? And you have some simple heading, a couple of headings, an image, a raw HTML, another heading, a YouTube widget, and a raw HTML. Okay. Again, this is only for testing, so that the TAs have the same data for everybody, and they can quickly go through and test everybody's websites. Yes, right. But again, you're welcome to add more for test for just to play around. This URL is a URL that maps to a random image generator. Maybe. What? Oh. What? Okay. I'm being blocked, but you're not. I think it's a firewall that I have on this particular machine. Anyway, so for widget service, same thing. You're going to have a CRUD operations, right? That look very similar to the ones you created earlier. All right, so controllers. So these services are going to allow you to um, uh, um, uh, access the data, right, from anywhere on your application. Right? Anybody can ask the service, hey, service, give me this data, right? And it's going to be responsibility of controllers for retrieving this data to feed it to the views, right? Remember, in a model view controller, it is the controller's responsibility to listen for incoming event handlers from the client, right? As the client clicks and drags and types and moves the mouse around, right? It is the controller's responsibility to handle all these events, act on those events, right, by manipulating the model, and then providing the results of that model back to the client for rendering. Okay, so for each one of the views, there's going to be a dedicated controller for that particular view, and we're going to follow this file structure where you're going to put all your views and controllers, right, under the views directory, and under the views directory, you're going to have, the various entities, user or website or page or widget or whatnot, right? And in there, you're going to have two directories. One is a templates directory that's going to host all the HTML templates, right? And then you're going to have a controllers directory, which you're going to have all the controllers for each one of the templates. Each template will have its own individual controller. Right, so the login template will have a login controller. The profile template will have a profile controller. The widget list will have a widget list controller, and so on and so forth. Right, so it'll be a one-to-one for them, for each one. Right. Now this is a common way to organize it, where you have all the templates under the templates directory and all the controllers on the controls directory. So this is a very common way of organizing it. Typically, you might have all the designers and folks that make things look pretty, work under the templates directory, and then you'll have all the JavaScript developers, right, spending most of the time on the controllers and the services directory, right? Interacting with the server, fetching data from a server, from a database, and whatnot. Yes. So this is a very common way to organize. I'm going to rewrite this so that it's a little cleaner. So this would be, actually this would be under here, right, controllers. And so this also would be website, and this would be templates. Right, you would have all the templates in here, and you would have all the controllers in here. Oops. There we go. And these would be controllers. And these would be the controllers, right? Last semester, I had it as optional. And I gave a couple of alternative ways to organize the code. And so I had these as an optional way of organizing it, and it was just maddening to grade. Okay, because everybody was doing something different. So we were just going crazy trying to give partial credit or this, that, or the other. So I'm just gonna pick one. Right, I'm just gonna go with this directory structure. Right, and please everybody follow this. Again, your particular team, when you actually go in the industry and work in the team, they'll come up with a directory structure for you. Just stick to whatever the team says. Typically, the team has agreed on how to organize your file structure, and just follow that. All right? But again, this is a very common way that it's done in industry. Here I give you some examples on how to create a controller. Today we'll be creating our own controllers, and I'm just showing you how to just a snippet of code what controllers look like. And these are all the controls that you're responsible for. You'll also need to tell each one of the templates, right, that you're navigating between the various templates, who is its controller. So you'll need to tell, hey, login template, your controller is the login controller. And hey, widget list template, your controller is the widget list controller, right? And you need to map those in the routing, and we'll do that as well. You'll need to also each one of those input fields that you have in all your forms. The forms will be able to create new widgets, create new websites, create new pages, or edit them, right? All those fields will need to be bound to using ngModel to variables so that the controller can get a hold of those, right? Or populate them from the controller, right? The controller is going to feed data back and forth, right, for a template to render these things, yes? So we'll need to bind those things. Right, we'll need to populate, for instance, if you navigate to an editor page, right, like a widget edit or a page edit or a website edit, right, you'll need to go fetch that particular page or fetch that particular website and then populate the form with the data for that particular website or that particular page or that particular widget, right? So that you can then edit it and then update it. Yes? So here's just a reminder that you need to do that. And again, this is an example that we're going to go over in class where you're using the service to go fetch a particular user if you know its particular ID, user ID, that comes in as a parameter in the URL, right? So we'll do that later today, perhaps. Popular list pages. If you navigate to a list page, like the list of websites or the list of pages or the list of widgets, right? You'll need to retrieve the list for the parent, right? So for instance, for websites, you'll need to retrieve all the websites for a particular user, where the user is the parent, right? And if you navigate to the list of pages, then you'll need to retrieve the list of pages given the parent website, right? And so on and so forth, right? So you need to retrieve the parent's ID. Based on that parent ID, you need to retrieve all the child nodes for that particular parent, right? So again, I gave you some ideas here. If you're listing the list of websites, you need to retrieve the user ID as a parameter from the URL, and then retrieve the websites for that particular user, right? And then pass it on to the view for rendering using an ng repeat, right? And again, we'll do all this in class. Event handlers, you need to create event handlers. So for every button, for every click, for everything that the user can touch, right? We need the controller to listen for those incoming event handlers. So you need to create those event handlers, and they need to be declared at the top of the controller, right, as a best practice, and then implemented then, below, towards the bottom of the controller, and we'll do that today. Okay. What else? Merge heading, which is merge. Heading. Oh, okay. Now one of the more challenging pages will be the widget list. Right? The widget list right now, it's hard-coded, right? We have some heading widgets, we have some YouTube widgets, we have some image widgets, we have some raw HTML widgets, yes? And they all, generally they have the same pattern, right? And they're all in a div with a class widget, right? WD widget or something, right? They all have a toolbar, but then they're all different, right? Some of them are rendered using H1, H2, H3. Some of them are rendered with iframes. Some are rendered with IMGs. Some of them are rendered with paragraphs, right? So we need to generalize that mechanism, right? Depending on the type of the widget, we need to render one way or another, right? So what we're going to do is that we're going to grab those hard-coded HTML snippets that we have right now, the H1s or the iframes or the IMGs or however we implemented the widget, right? We're going to grab those and we're going to make templates out of them, right? Reusable templates, right? Which we can then inject, right? Depending on the particular URL for whatever image it is, or whatever YouTube URL we're using, or whatever HTML hard-coded HTML that we have in the database, right? And then we're going to inject the content and then feed it the data so that it reconstitute as its HTML, right? So we're going to put them in separate HTML documents, and then we're going to include them as we go, right? We're going to iterate over the array of all the widgets, and as we iterate, we're going to use an ng switch. We're going to say, okay, we're going to switch on the type of the widget. right? If it's a heading type widget, we're going to inject the heading widget, right? Or if it's the image, we'll inject the image widget. Or if you have the YouTube, we'll inject the YouTube widget, okay? As we iterate over all the widgets. Make sense? Anyway, we'll look at this in more detail. This is the structure of the of your file system. And again, last semester this was optional. I'm making it not optional this time. Okay, these are all living under here. Actually, yeah, let's do this. This also was a nice idea that I made optional. I'm gonna make it have to implement this way. Okay. There we go. All right, I'll finish this up tonight. The page flow is the same. Deliverables. It's again, you're gonna tag it as assignment 3, right? And you're gonna provide it by the URL to the GitHub and the hosted environment. Okay. What else? I think that's it. Any questions? All right. Let's keep going.